Okay, so what we're going to be doing today is more on optimization. So we're going to start with this first problem. The sum of the perimeter of a square and the circumference of a circle is 20. Find the dimensions of the square and circle that produce a minimum area. So the perimeter of a square, if with a side length of x, is 4x. The circumference of a circle is 2 pi r. So if I add 4x and 2 pi r equal to 20, I can solve this for r and say that 20 minus 4x over 2 pi must equal r. All right, we will now replace r in the other equation. So x squared plus pi times, that was an arrow sign, 20 minus 4x all over 2 pi squared. Okay, so now that I have this, we can use our calculator, or we could do it by hand. The instructions don't say to use a calculator, but I kind of feel like that would be okay. So let's practice with our calculator. All right, so in order to do this, we are going to find a minimum area. So we have two choices. We can use the candidates test, or we can use a modified version of the first derivative test. I always want to use the candidates test if I can. I just can't always do that. Can't always do either one of them, actually. So we can't do the candidates test unless we can create a closed interval where the function is continuous. Well, I think in this situation here, we can do that because if the perimeter has to be 20, then x can either equal 0. Let me write it like that. In which case, the entire, when I said 20, the perimeter and circumference added together has to be 20. So if we let the side length of the square be 0, then the entire 20 units are taken up by the circumference of the circle. If I let the radius be 0, so that there's no circle at all, then the entire 20 is composed of the square, and 20 divided by 4 is 5. So I think we can clearly agree that this function is only meaningful on the closed interval from 0 to 5. Now that I've got a closed interval, I can use the candidates test. Because A is continuous on this closed interval. So the extreme value theorem tells me an absolute maximum must exist. Let's find the critical numbers. So we need the critical numbers. So that would be 2x plus 2 pi times 20 minus 4x over 2 pi times the chain rule, which is a negative 4 over 2 pi. You'll see that some of the 2 pi's would cancel out there. We could also, if we're using our calculator, we can go ahead and use it. We could say F3 differentiate, and we can type in the equation and have it take the derivative for us. And we all need to know how to do that. X squared plus pi times, and I'm going to put two parentheses here, 20 minus 4x divided by parentheses 2 pi. Make sure you put the 2 pi in parentheses as well, or else it'll just divide by 2 and multiply by pi. Squared. And I'm going to take the derivative with respect to x. Check the pretty print. Make sure it looks like what you have here. Then you can see the result. So that's actually a lot cleaner, isn't it? They did a lot of simplifying for us. But I think, if we think about this, we can see that it's going to be the same. The 2 pi will cancel out. We'll only have a 2. That'll reduce. So it'll be a pi. So that'll end up being So we could go through and check it, but we're just going to take it for faith. All right, next thing we're going to do is we're going to solve for when this equals 0. So what we'll do is we'll graph it. So we'll go to y equals and we'll graph it. Now, since we've got the derivative right here, maybe we want to go up there and just hit diamond, copy, and then diamond, paste, and there we have it. And we'll graph. I don't know what my window's at. Usually I start with a standard zoom. It would probably make sense for me to go to my window and set my 0. Wow, 0 to 5. Absolutely perfect. So yeah, because that's the interval that we're looking at, right? So I will then find my 0. So I'll say F5, 0, lower bound, and upper bound. So that's 2.800. So to do the candidates test, I simply need to evaluate at each one of these values. At 0, 2.8, and 5. So we'll go and we'll do that. So my area function is x squared plus pi times 20 minus 4x divided by 2 pi squared, such that x equals 0. So the first answer is, well, let's get a decimal, is 31.831. Make sure you check the pretty print that it looks correct. The next one, we'll do 2.800, is 14.002. And the last one is at x equals 5, which gives me 25. So the dimensions that give me the minimum area is when I'm kind of run out of room, I'm afraid, is when x equals 2.8. So we'll just say it. The dimensions are square side is 2.8. And the circle's radius would be, there's how you get the radius right here. So we'll say 20 minus 4 times 2.8 divided by 2 pi. And that gives me 1.400. So that will give me a minimum combined area by the candidates test. Find the dimensions of the square and the circle that produce a maximum area. Well, we can see that that's when x equals 0. And r is, so the r is going to be the full 20 divided by 2 pi. Again, make sure you put it in parentheses like so. So r is equal to 3.183. In other words, all dimension in the circle. So if you want to maximize the combined area, you need to have it all in the circle. Okay? All right, what I'd like for you to do now is practice 4.2. The acceleration of a particle moving on a horizontal line is described by A of t is equal to t squared plus 1 cosine of t for t between 0 and 7 on a closed interval. At what time is the particle's velocity decreasing most rapidly? Okay, this is a great little question. It's very easy to do if you know what the question is asking. The question asks, what time is the particle's velocity decreasing most rapidly? So, in other words, it's asking for us to find a minimum acceleration. Acceleration is a rate of change of velocity. velocity is decreasing whenever acceleration is negative. The more negative the acceleration, the more rapidly the velocity is decreasing, or the greater the magnitude of it, right? So this is simply asking for a minimum acceleration, and it's also telling us that that acceleration will be negative. So if we get a minimum acceleration that's positive, then I done goofed on the question, which is actually totally possible. So let's find out. So I'm trying to find the minimum acceleration. So what I need is the derivative of acceleration. So derivative of the first times the second plus the first times derivative of the second. And again, we could also ask our calculator to do that since it's a calculator question. But if you're using the derivative to solve for when the derivative does something, show them the derivative. Even if you just typed in your calculator and told it to find the derivative. Let's review how to do that. Second, 8. Type it in. T squared plus 1 times cosine of t with respect to t. And there it is. And that's pretty much exactly what we have. Just took negative and put it there. Okay. All right. I'm now going to go to my y equals. And I'm going to graph it. I'll use x, though. Make sure you put a times between x and cosine, or else it'll think it's some new weird variable. All right. We're looking from 0 to 7, so I'll set my bounds there. And we'll see if we can't find places where this crosses the x-axis. So there looks to be a couple of them. One there and one there. Oh, wait. Hold the phone. There's now a third. Okay. Let's find those zeros. So F5. 0 lower bound there, upper bound there. So, and I'll use t here, okay, because we had t in our equation, 3.616. So a prime of t equals 0 at, all right. Let's go find the other one. Now, this shouldn't be a minimum because it's going from positive to negative, but in order to get full credit, we're always going to show all critical numbers because that's part of the candidate's test. All right, so t equals 0.768 and t equals, okay, 50. Sometimes it goes a little faster if you press second and then the right arrow. All right, any second now. There it is, above and below. So that's t equals 6.572. All right, we'll just simply evaluate each one of these places and the endpoints. T and a of t. 0, 0.768, 3.616, 6.572. So we found, oh, and 7. So we found all the critical numbers. That's when the derivative is equal to 0. Now we're doing a candidate test because we have a continuous function over a closed interval. And we evaluate the original function. We're trying to find the smallest negative value here. Just deleting my derivative part. And then I can say such that t equals 0. So that is 1. Such that t equals 3.616. That is a negative 12.521. Oh, I put that in the wrong place. That's negative 12.521 there. This was supposed to be, I apologize, I skipped one. 0.768. 1.1. 1.144, it looks like. All right, next we'll do 6.572. Oh, that one's big. 42.361. And finally, we'll do the other endpoint of 7, and that's, oops, I don't want that. There we go. 37.695. So the velocity is decreasing whenever the acceleration is negative, and it is most negative. It's actually only negative once, but this is a minimum of the acceleration. So the particle's acceleration is at a minimum at t equals 3.616. So the particle velocity is decreasing most rapidly. I'll make a note because A of 3.616 is negative. Okay, that was important, I think. All right. So yeah, not a neat problem, I think. Okay, example 4.2. A closed box with a square base is built so that its volume is 72 cubic centimeters. If the bottom of the box costs 60 centimeters squared, the sides cost 35 cents per centimeter squared, and the top costs 30 cents per centimeter squared, find the dimensions and the cost of the least expensive box. All right, so let's just write a function. This is a closed box, so it has to have a lid. Sometimes they are open boxes. Okay, the bottom cost this much per square centimeter. Now remember, it said it's a square base, so I'll call that x. Okay. So I know that x squared will cost 60 cents. Now to find the sides, though, we need to find this height, which I'll call h. Well, they told me the volume was 72. So if the volume is 72, then I know that x times h, which x squared h, has to equal 72. Solving for h gives me 72 over x squared. So I can now use that to find the other side length. So there are 4 sides, and they are 35 cents per square centimeter, and the area of those sides are the length times the width. So x times 72 over x squared. All right, lastly, we can find the top. Well, the top is an x squared again, so that's 0.30 times x squared. And that equals the total cost as a function of x. I'm going to go ahead and just clean this up just a little bit, though. 0.60x squared, 0.35 times 4 times 72 is 100.8. And then the x over x squared becomes just an x. All right. Well, here's the problem. We can't use the candidates test because there is no smallest value that x can be or largest value. I can make x can't be 0. I'd be dividing by 0. And therefore I wouldn't have a volume of 72. But x could be a microscopic fraction, right? And then the height of the box would be some enormously large value. So we're going to have to just use our modified first derivative test. So let's first get the derivative, which I think would be easy to do by hand. That's 1.2 x minus 100.8 over x squared plus 0.6 x is equal to c prime. And now we just need to solve this equal to 0, which really wouldn't be that hard either. These two make 1.8x. Move that to the other side. So I get 1.8x cubed equals 100.8. And then I'll use the calculator at this point though. 100.8 divided by 1.8. And then I'll take the cube root of that. So I'll just raise it to the 1/3 power. So x is equal to 3.826. All right. Now, it would be actually nice to graph the derivative, because then I think we could see something, right? We could see whether it's going from negative to positive. So let's go ahead and graph it. So all that algebra, and I threw it away, I know. So that was 1.2x minus 100.8 over x squared plus 0.6x. And I'll graph it. I did not set a very good window, though. Let's do F. Let's see here. I would say like maybe x could be as big as 20. I don't know. Let's take a look at our table, actually. That'll help. Oh. What? I lost it. I lost my equation. 1.2. Well, I get the thrill of typing it in again. 1.2x minus 100.8 over x squared plus 0.6x. Hit enter. Okay, there it is. I must not have hit enter. Okay, there it is. Right there. We can see that C prime is going from negative to positive, and that's the only critical number. So because C prime changes from, well, let's not say that, because that's the first root of this. We're going to do a modified. We're going to say that it's negative always, because C prime is negative on 0 to 3.826, and C prime is positive 3.826 to infinity. See, what we're saying is it's that C prime is negative always, and then it's always positive. So that means it's going down until a value, and then it's going up. X equals 3.826 locates a minimum cost. Okay? So the dimensions would be 72 divided by 3.826 squared. So they are 3.826 by 3.826 by 4.919. And we got it by using the modified first derivative test. Okay. Practice 4.3. A right trapezoid with a height of length 2 along the, that's kind of confusing, height of length, but a height of 2, along the x-axis is inscribed within the portion of the curve y equals negative x cubed plus 4x squared that lies within the first quadrant. What is the maximum area that the trapezoid can contain? So what this is saying is that the trapezoid is required that this be this right trapezoid have a height going this way of 2. Here's your B1 and your B2. The area of a trapezoid is 1/2 B1 plus B2 times height. Oddly enough, they'll tell you the area formula for a circle. Well, maybe not. They'll tell you the area formula for a rectangle, I think, on the... No, they won't. They won't tell you a trapezoid. They'll tell you volume of a cube. They'll tell you all sorts of area formulas, but they don't tell you trapezoid, because that's considered important to calculus. But I want you to find the maximum area that this trapezoid can contain if these 2 points have to lie on that curve. Give it a try. Okay, so let's go over this one. We have a trapezoid, and if we let this be x, if we know the length of this slide here is always 2 more, this will be x plus 2. So these points here, this height is defined by the function. So this height is negative x plus 2 cubed plus 4x plus 2 squared. And this height over here is just negative x cubed plus 4x squared, just as it is. So our area is going to be 1/2 times negative x cubed plus 4x squared plus negative x plus 2 cubed plus 4 times x plus 2 squared times the height of 2 that's constant, which actually cancels out the 1/2. So let's take our derivative, but let me just clean this up a little bit. All right, we'll take the derivative now. A prime is equal to a negative 3x squared plus 8x minus 3 times x plus 2 squared times the derivative of the inside, but the derivative of the inside is only a 1, plus 8 times x plus 2. All right, we now need to find the maximum on where the x value, though, is limited, because the x value can only go from 0 to 4. Actually, it can only go from 0 to 2. So I'm going to say that A is continuous on the interval from 0 to 2. Because we have to be in the first quadrant that's in the problem description. So let's find the zeros of this function. And we could probably solve it algebraically, not too difficultly. But we'll just do it by hand. We'll just do it by calculator, I mean. Okay. Well, there we go. So I'm going to find that value. F5 for math. 0. And I got a long way to go over here. There we go. Lower bound, upper bound. And it's 1.215. So A prime of 1.215 is equal to 0. And then let's just make a little table for t and a of t. Let's test 0, 1.215, and let's try 3. Or no, 2 was our maximum. Okay, so here we go. My area function is negative x cubed plus 4x squared minus x plus 2 cubed plus 4 times x plus 2 squared. And I'm going to say such that x equals 0. I get 8. Then I'll say such that x equals 1.215, which gives me 12.225. And finally, we'll say such that x is equal to 2, which is oddly enough also 8. Interesting. I find that surprising. Well, it is a triangle with a height of 8 and a base of 2, so yeah. The other one's a height of 0. Oh, yeah. It's the same triangle. It's just reversed. So that's pretty cool. So the maximum area by the candidates test is 12.225 units. And that's our last problem for today. So I hope you got something out of that, and let's just go to practice.